guys, this is the last video that we have to do for this semester. And I don't know about you, but I am pumped. No more math. No more math. No more math. No more math. Okay, so exciting. I don't know about you, but I am completely ready to be done with math for this semester. Nothing against Miss Benzie, because she has been a delight and absolutely one of my favorite teachers that I've had for math. I am just done to be mathing. No more math brain for a little bit. Well, probably. I don't know. But let's jump in and get started. Alrighty, final project. Let's get into it. So, how is speed relevant to measurement? Let's start with metric measurements. We use the metric system to measure length, weight, or volume of an object. For example, we had to determine how fast we are moving while standing still. And I don't know about you, but at first thought, you're like, well, you're not moving at all. And this is where you are wrong, because when we are standing still, we have to use the Earth's rotation. And when we use the Earth's rotation, we use scientific notation, and we find that the Earth's rotation is 460 meters per second, or 1,000 miles per hour. So when you're standing perfectly still, 1,000 miles per hour, which is crazy. So we did the graph for this, and we used cosmic momentum. We used the local group, the Milky Way orbital speed, the Andromeda galaxy, the solar system orbit, and the Earth's orbit. And we did a total of it. And as you can see by the graph, I mean, the miles per hour are just astonishing. Like, the group as a whole, I mean, we're a little bit over 700,000 miles an hour. So it's pretty crazy. Let's get into the next one. How is size relevant to measurement? Size is relevant to measurement to gain perception through visual assistance. So when you're describing to somebody, you know, it was so big, a lot of people aren't going to visually see a ruler inside their head and be like, oh, okay, I know how big that is. So visual aid is always good to represent that. Honing in on those sensory attributes, we can evaluate said measurement better. For example, when we use the Scale of the Universe app, it gave the measurement of said object and an example to further demonstrate how significant said item can be. I.e., for me, it was the grain of rice, because I eat rice every other day, probably. I mean, I eat rice a lot. So the grain of rice by itself is 5 millimeters long. And when I say that to you without a visual aid, I don't know of any of you who know, who are like, oh yeah, I know exactly how big that is. Yet, as you can see from this little clip it right here, the grain of rice compared to a coffee bean or a sunflower seed is quite small. Yet, if we eat a whole bowl of rice per day, you will eat 300 million grains of rice in your lifetime. Crazy to even think of. Let's move on to the next one. So, asymptote, what is it? Well, thanks to Google, we all know. Well, at least me, I didn't know. An asymptote is a line that continually approaches a given curve, but does not meet said curve at any finite distance. The asymptote presents a value that gets closer and closer, but it never quite reaches on the graph. It's a horizontal, vertical, or slanted line that a graph never touches but approaches. So as you can see with the half-life, which I didn't even know what a half-life was. Again, this is probably one of my second favorites out of the whole semester that we've done. we had to find medicine and see what the half-life of it is. So on this graph, as you can see, it doesn't quite touch, but it gets very close. Let's go ahead and move on to the next one. What is infinite division? Infinite division means that any section of time and space can be divided into an infinite number of possibilities, or smaller and smaller pieces. This is important because of the property of stable and probability distributions. So as you can see from the numbers of half-lives elapsed versus the fraction remaining and the percentage in hours, you get more information from it. So you can see from 0, there's 100% remaining for 0 hours. Yet if you look at 5 and like 1/6 of the time is remaining, the percentage is equal to 6.25%, and that's 7 hours in your system, essentially. That's pretty crazy. Let's move forward. Okay, what is theoretical probability? Theoretical probability is based on reasoning written as a number of favorable outcomes to the number of possible outcomes. So this being said, when we did our odds for, our odds against, the probability, reduced fraction, decimal to the nearest thousand, and percent, you can see the odds for the certain amount is pretty easily read. But this leads me into our next slide. What is empirical probability? Well, empirical probability, that's a mouthful, is a ratio of the number of outcomes in which a specified event occurs to the total number of trials. To emphasize theoretical probability, we use empirical probability to find out the ratio of the number of outcomes. So as you can see in this little clip over here on the left, we did odds and even numbers for the dice rolls. And you can see the odds for and the odds against on the bottom. So you see how the outcome is, I have them color coded. So the ones that aren't white are the odds for and the odds against. Okay, so what is the law of large numbers and central limit theory? So the law of large numbers is a theorem that describes the result of performing the same experiment a large number of times. Notice the graphs. The first graph has a limited amount of experiments versus the graph on the bottom that has more data. Notice the graphs become less sparse when the data has increased. Central limit theorem establishes in some situations when an independent random variables are added, their sums normalize towards a normal distribution. Okay, so data or not true data? That is the question. Misleading data is always beneficial to somebody, whether you're trying to push an agenda or prove somebody wrong, or one of those two, the misleading data comes into play. The rate of unemployment is what we're going to use for this example versus during the presidential year. If you notice on the left-hand side, it shows that Clinton had a vast more unemployment rates versus Bush's years in office. However, this is where misleading data comes into play. The rate of the unemployment when said president was in office versus the favored president, at first glance, the bias chart expresses the unemployment rate was lower. Yet when we utilize the same data, but start each graph at 0, the skewed data becomes evenly distributed. There was actually only a 0.02% difference between said presidents for the rate of unemployment. So if we start all our graphs at 0, we can actually get true data, which is something I didn't think about until we had to do this assignment. I don't know about you guys, but it makes me kind of curious as to what else that I've seen, i.e. News or in documentaries, what is misleading. So let's move forward. Visual dissolution. Notice how Fox News displays this pie chart showing all the contributors for the funding of a new arena. If you notice how the unknown contribution on Fox News pie chart looks substantial due to the visual dissolution, in reality, when you go ahead and put the proper information in, i.e. the numbers, and do the formula for it, you find out that the mysterious stranger only did about 2% towards the whole pie, which again is like nothing. So let's go ahead and move forward to what is correlation. Correlation is when two sets of data are strongly linked together. If you notice on the top, you will see the hospital discharge diagnosis versus genetically modified corn. So when correlation is the variables that fluctuate, if it fluctuates positively when the variables increase together, then that's a good, well, could be a good or a bad thing. And then it fluctuates negatively when one variable increases and the other decreases, which could mostly be a good thing or a bad thing. But as you can see, the incline for the amount of people that were diagnosed with peritonitis versus the corn, it seems to have gotten lower as the peritonitis increased. However, when we looked on the bottom for the genetically modified corn versus a certain amount of people that have a certain cancer, you'll see that the both increase. So let's move forward. Is this causation or is this just fantasy? Well, let's find out. Causation is when one variable influences another. The value of the data, whether the fluctuation increases or decreases as a result of the other. Whether the fluctuation increases or decreases as a result of the other, sorry. The FDA claims that no harm can come from foods that have GMOs, but if we look at the data, the body is built to reject foreign objects. So as you can see, the bowel disease plotted against the genetically modified corn just keeps increasing and increasing. So when we introduce something into our body, at first the body fights against it. But once you continue to do something and it becomes a habit, your body becomes more immune to it. I was going to say less immune, more immune to it. And then your body just accepts it as being normal. And this leads to issues in the body, like bowel disease, for example. Just personally speaking, I've switched from, I know everyone's going to be like, oh, the organic hype. It's not a hype. I've been eating cage-free organic eggs for about a month now, and that's where I get a main source of my protein, being a pescatarian. So I haven't had nearly the amount of stomach issues that I had just buying the cheap, regular, like, great value eggs. So I think this taught us to actually read what we're putting into our body. Let's move forward. Probability. Binomial distribution. Binomial. I can't say it. I can never say it. Binomial. There we go. Binomial distribution is a fixed number of trials. Each trial is independent to others. There are only two outcomes. The probability of each outcome remains constant from trial to trial. Not studying for an exam, for example, and expecting to get an 80% on it. You're in for a big surprise because you only have a 4% chance of getting a passing grade. And that's what we did with the binomial distribution. So when we did these problems, it was a very long process and sometimes frustrating, but having the little cheat sheet to help you express the problem in full is really helpful. So just like when somebody buys a lottery ticket, binomial probability comes into play, which refers to the probability of the exact, which is, we're going to call it X, success on the N repeated trials is an experiment which has two possible outcomes. So for this, we talk about the winning lottery tickets and what's the probability of actually winning a lottery ticket. Well, if you look at the total winnings amount and then the outcomes and the probability, I mean, I've never been a gambler. I don't think I've ever gambled in my life, honestly. I just feel like it would just be a waste of time. Instead of gambling, I'd rather just work really hard and earn it than doing that. But, I mean, this was a good example to show people who actually do gamble the probability of them actually winning something. And it's actually pretty astonishing. Like one of the, winning tickets for 25. It's a outcome of $20, and you've got a 1 in a 1/60th chance of winning that. In my opinion, I just don't feel like it's worth the money to waste. Just save it. So, what is the likelihood of being obese? This one was a pretty big shocker for me, at least. So probability is the chance of an event occurring. With the research of how many people in the US are obese, it was staggering that, 93,300,000 United States Americans are considered obese. And now incorporate the percentage of Americans that also have high blood pressure, which is 9% of the population, it's just, ugh. And that's all I could do is like make a weird noise because it just kind of blew my mind when we had to do this homework. I was very shocked by that. It's very sad, but I mean, the numbers are just astonishing. So let's move forward on that note. Let's see. When researching on different states in the country, how likely it was that these percentages fluctuate depending on where you live, I looked up my hometown of Chicago, and the percent of obesity there is 31.1%. But they have really good pizza, so I could understand why it could be that high, but it was still pretty crazy to me. Again, I was just, the only thing I could do was make a noise. So let's move forward. And I apologize because Google Slides hates me, and I haven't figured out how to properly get it to sync up with my Mac yet. Maybe soon. Reckless probability. So this one we were talking about driving impaired, which to me, in my opinion, is it okay to say moronic or idiotic? Because I mean, if you're going to be selfish and you know you're going to impair yourself one way or another, it's your responsibility and duty to make sure that whenever you decide to leave said place, that you call a taxi, or you have a DD, or you just don't get impaired to begin with. I mean, as adults, we have this luxury of being able to have a drink after we have a hard day. We earn that. We pay taxes. We work really hard. Cheers on that. But you impaired so bad to the point where it affects others around you, it's not okay. That's just negligence on your behalf. So we had to study the mean, the median, and the standard deviation to calculate the data. As you can see, the probability of driving impaired on a rural road in 2008 was 22%, versus in the city, which was only 5%. It's really staggering and like quite, I don't know, appalling, like the statistics on this, that people can't be adults and kind of like, you know, get it together. But hey, what can you do? But move forward. So I'm going to steal the words of you, Ms. Benzie, the polyprobability, which I love. So we use stratified sampling to figure out the percentages. No, that's the next one. I'm getting ahead of myself. My apologies. The probability of polydrugging, which is a phrase coined by Miss Benzie, which I love. That is so, I know it's really bad. It's a bad reference to say that is cute, but it's like the cutest, like the cutest way to call somebody a drug addict. Like, oh, they're polydrugging. I forget myself. The chart breaks down several polydrugging instances, but what the chart doesn't break down is, like, for example, let's say somebody decides to have a glass of wine and they totally forget, which would be hard to do, but they totally forget that the medication that they're on doesn't mix with alcohol. I don't really, even with a chart that's not as lopsided as mine, I couldn't really see anybody who had charted alcohol and medications. Then again, like I said, in my glasses, I'm waiting for them to come in, so I could be completely blind, and you can point that out to me or leave it in the comments for me, Miss Benzie, and let me know that that's what this chart is missing. But I feel like that would be a big portion of forgetting that you took an antibiotic earlier in the day and then deciding to have a glass of wine, you know, to wind down from a hard day would be a big one, where it's not really reckless, but as long as you're at home, even then, I don't know. People need to be responsible adults. Stratified sampling. So we use stratified sampling to figure out the percentages of political parties. I'm not going to touch that subject. That is something that I don't get involved in. Politics are not my forte. Maybe one day, but not right now. But we used the stratified sampling to figure out the percentages of political parties in the US. When using the stratified sampling is when the population, so what it is when the population is partitioned into non-overlapping groups. Republicans, Democrats, Independent, Unknown, as you can see on the chart. So that being said, United States poll on the political party is Independent is a huge chunk of it, and then Republicans and Democrats are very close, and then the 3% of Unknown. I'm just reading my notes, sorry. Random sampling. Random sampling helps in gathering data, statistically speaking, random samples in subset of individuals chosen from a larger set, chosen by chance and randomly, which we did for selecting the probability of men and women in the armed forces and what branches. So we kind of selected some at random for the number of women who were not only in the Army but in the Marines, or for the number of women who are not only in the Navy but also the Air Force. As you can see in the graphs, there's a lot more men in certain branches. Well, there's a lot more men in the armed forces as a whole, but there's a lot more women, it seems to be, in the Air Force than in the Marines, for example. Let's move forward. Coefficient variation. Coefficient variation is also known as relative standard deviation. The standardized measurement of distribution, frequently or probability distribution, for example, the Army recruits in the Heights versus the Army recruits of random shoppers. So the Army recruits, they usually are subcategorized, if you will. So you have men and you have women, and usually in the armed forces, there's not that big of a fluctuation. As you can see, there's a little bit of a fluctuation, but I feel like for the Army recruits, they stuck to one specific gender versus the height and like age. You have to be a specific age to be in the Army too. So the height of random mall shoppers, though, could be men, women, children, and that's why it's so sporadic when you look down and you see the randos is what I call them, in inches versus the Army recruits. Because the Army, the standard deviation for the Army is like 4.03, and then the standard deviation for the randos is 14.07, which is a big difference. So, that being said, let's move forward. Box and whisker plots. I wouldn't say necessarily the bane of my existence, just frustrating until you understand it. So, in a box and whisker plot, let's explain it like this. The ends of the box are the upper and lower quartiles. These boxes span the inner quartiles, the middle of the stat percentage, if you will, or dispersion. The inner quartile range, the median is marked by the vertical line inside the box, and the whiskers are the two lines outside the box that extend to the lowest and the highest observation. So as you can see, essentially what I just said on the previous slide, it just shows you in just like a little bit less sporadic. So let's go to the next one. Data distribution. Some water would help. Distribution of outliers differ throughout this data sample. The outliers is a data point that is significantly different from the rest of the observation. Notice the ages from 16 to 24 seem to be major outliers for texting and driving. Perhaps this is because this is the age where you get your first cell phone or you start learning how to drive. Whereas, pardon me, people who have surpassed that, they don't care about, I don't care about getting text messages. I specifically use my app so that way when anybody tries to text or call me, while I'm driving, it tells them that I'm driving and I don't want to run over this little old lady by trying to read your text. If it's an emergency, text emergency, and it will automatically call me. Thanks, technology. You're the best. But I think that's, the distribution displays it pretty much right there, that the younger generation is too fixated on, oh, look at me, I'm driving, and Snapchatting while driving, and that leads to an accident. Let's move forward. Standard deviation. The standard deviation, a quantity calculated to indicate the extent of the deviation as a whole. For the ages of 16 through 24 is standard deviation is 6.2%, whereas the standard deviation for the ages of 24 through 69 is 1%. If you look on the bottom, that bell-shaped curve right there is the frequency of data. Okay, let's do confidence intervals. Confidence interval is a range of values so defined that there is a specific probability that the value of a parameter lies within it. In this case, it's the BMI, or body mass index, for women and men of America. The constant confidence intervals for women are the 154 with a little weird plus symbol and minus symbol, 0.40, versus the men who have the 0.195 with the weird symbol, and then 0.385, which means, Benzie, if I didn't tell you how to do that, whenever you go into Excel and you click on inserts, and there it will say mathematical symbol, you'll click on that and we'll give you a list of mathematical symbols. So we'll have that little weird plus minus sign thing that you're looking for. Having said that, let's go to the z-score. The z-score is the number of standard deviations from the mean data point that it is. For my BMI, mine is 18 versus, which is going to be at the top right there, versus Jackie's, who is going to be at 20, and my friend Laura, who's at 21. So my z-score is negative 1.6. So it's going to be towards the left. And then Jackie's was negative 1.3. And so so was Nishi's. It was negative 1.3. The probability of being lower than me was a 5% chance, and anyone being higher than mine was a 95% chance. For Jackie's, anyone being lower than hers was a 1% chance, and then anyone being higher than hers was a 99% chance. And then for my friend Laura, who is Asian, so I had to put that in, who is Asian, and we call her Nishi by her last name, she had a 0% chance of anyone being smaller than her, or like her BMI being lower, and then 100% chance for anyone having higher BMI than her. The American struggle. Wealth is the outlier here. As we know, the outlier is an observation that lies an abnormal distance from other values. Thus, Americans' distribution of income comes into play. There are far more people who are in need than those who are not and have more than enough. hence the skew of too many values that fall within the normal range, i.e. the graph in the top right-hand corner. It was astonishing to me how many people are in actual need versus the people that are not. Let's move forward and let's talk about skewed from the beginning. I like play on words. Where starting a business is hard, to draw in more profits seems to be the most difficult. As you can see here, this was the flamethrower projects from the guy that did Tesla, trying to sell flamethrowers. As much as we would all love one, you don't genuinely have a need for one unless you're like a crop owner. You gotta get rid of some crops, then you can like flamethrow the whole field if need be. But I don't think a lot of us are in agricultural worlds. Well, we are, but anyway, I digress. The draw to bring in more profits. As you can see, he wouldn't start making a profit until he hit about 220 in sales, and the output was 2466.8%. By my little Pac-Man in the corner, he doesn't quite reach that. It doesn't quite get there. That's where the data skewed comes out. He won't initially make what he shelled out until he reaches that number. Hence why he failed. So let's talk about skewed data. Skewed data is the distribution of data. If one tail is longer than the other, a positive skew shows the data is longer in the positive direction, whereas the distribution is negative if the data is longer in the negative direction. In this case, the data is longer in the positive direction, but is it really positive? I don't think it is. I mean, the number of people that are in need versus the people that have is just mind-blowing. Taxes. So filing taxes with any of the three major options, i.e. head of household, single, or married, becomes an issue because of tax brackets. Here shows like head of household taxes and the distribution of how much taxes they paid in versus annual pay versus what's left over. Property tax alone, people paying in for all three filing groups, collected over $1,119,958 alone. That's just in property tax. That's not including the cost of any of the goods offered, employee pay, insurances, or utilities, as far as if you were a business owner. Taxes do increase for those who have a higher wage bracket, but look at the cost of those who barely get by. Supporting local business is a start towards a dent in the debt of the business owner and the struggle that they deal with. So let's move forward. So again, we use percentages for the annual pay, the deduction percent for taxes paid, and the net amount to discover which of the three major options have the most as far as taxes and what's left over. The tax bracket refers to the range of income subjected to a certain income of tax. Taxes as a single person, whereas in you're paying more, you get more back. As married, you guys are now two items, as I have learned this year for the first time being married. We owed federal taxes, but thank goodness we got a little bit left. Yay for paying for books out of pocket. Let's see. Tax breakdown. The taxes break down as follows. Depending on your income, you're placed in a bracket, whereas the government, take a percentage of your earnings and now add that to your filing status. You'll see how much taxes are taken out, especially if you're married. Hi, that was, oh geez, that was a lot. I mean, I'll just give you an example. So collectively together, we made $60,000 this year, which it doesn't seem like we did. My husband made more than me, obviously, because I'm only working part-time and going to school. Well, now that I have more hours, I'm working full-time and going to school full-time. But I digress. and you can see if one of us claimed head of household on top of that, I don't know if we would actually owe more or if we would actually get more back. But taxes paid in when you're in head of household versus what's left over, you actually have more left over than what you actually pay in. But annually, you pay a lot. Let's move forward. Simple interest rates and loans. So the linear growth is a pattern that grows by the same amount in each step. That being said, simple interest is the interest charged on a loan. That is determined by when you multiply the daily interest rate by the principal by the number of days that it elapsed between those payments. Again, this is another good thing to have for the cheat sheet when we had to actually break that down for an investment. As you can see on the bottom of the screen, the A stands for the amount equals the principal, and then the rate, the annual rate, and then the time in years. So it seemed really tedious, but it actually broke down a lot and it showed a lot. It makes me actually want to do that with my car payment to see how much I'm actually paying in interest versus what I'm actually paying for the car versus how much the car actually is worth. But I don't want to be really frustrated because I've already gotten frustrated as is enough this semester. So we're just going to leave that as is and move forward. Okay, so interest on interest. So exponential distribution is the probability distribution that describes the time between the event that occurs continuously or independently at a constant average rate, which comes into play with the compound interest. It's the addition of interest to the principal sum of a loan or deposit. This is what we learned with the mortgages. Personally speaking, I'm gonna have to actually do this with my mortgage to see like if actually paying in would be a little bit more. I don't know about you, Miss Benzie, but escrow is something that I had to learn harshly this year because my escrow increased, which means my mortgage increased. And that was something that I was gonna ask you personally, but I haven't been on campus. You haven't been on campus, so maybe we can, I don't know, Zoom about it. That being said, let's just continue on this this ongoing stream that we got going on here. So investing. Investing in a home is wonderful. It's a great experience until you realize just how much of the interest that you pay. And this is why I'm scared to do it on my own home because I'll probably get so mad I'll just scream really loud and my neighbors will be like, oh my God, somebody's getting murdered. Let's say, for example, you were to take out a loan and you were to put, like, let's say you take out a loan for 8% of what the house is, and you do a down payment of 5% for 5 years. And your monthly payments would be roughly around $2,083.38, where your annual payment of $25,000.61 is what you would be paying. And then the total of $125,003.05 would be what you're paying. But you'd be paying $14,603.05 in interest alone. Oh, does anybody know how like appallingly disgusting that is? Like it just makes me so angry. I don't want to talk about investments anymore. Let's just move forward. This is the thing that I might have to do, regretfully, but hey, it's part of being adults. Let's say you make the minimum monthly payment for your monthly payments. That amount will be $729 using the same information from the last slide. Months until it is paid off is 239 months. That's a total of $174,231. Now, the interest on that would be $63,831. What? Okay. That's the normal amount. let's see if you were to pay an extra $50 on your mortgage for your monthly payments. Your monthly payments would increase to $779. The months that you would have until it's paid off is 214 months. And then you would have a total of $166,706. The interest is $56,306, where yes, it's a little better. It's still repugnant is the best way I can describe that. But let's say if you throw an extra $100, how much would that help? Well, your payments would increase to $829. The payoff would be 194 months. It's a lot sooner. The total would be $160,826, and the interest that you paid is only $50,426. It's still too much for my liking. I don't feel like as homeowners we should have to go through that alone on top of everything else that we go through. This was one of my favorite projects that we did this semester, our financial report. For me, I'm going to school to be a mortician, so we had to pick 3 different states to where we would like to go. And for our financial report, we had to do that and look up the information for what our career pay would be in 3 different states. And we did a budget and a breakdown. Salary-wise, for a mortician in Portland, Maine, I essentially would be making $45,500 annually, which is a breakdown of $3,791.67 monthly. For Anchorage, Alaska, I would be making $41,747 annually, and then the monthly salary would break down to $3,478.92. And then in Salem, Massachusetts, the annual is $46,530 versus the monthly of $3,877.50. So, I mean, throughout those 3 states where they seem vastly great portions of the United States across the board, salary-wise, starting off, they're roughly in the same ballpark, which is, I found pretty shocking. But let's digress. The more money you have, the more problems you got. If you can, as you can see right here, what I did is I did a breakdown of everybody eats eggs, everybody eats cheese, everybody has milk in their fridge, mostly. Where in Salem, I would make the most as far as how much I would make salary-wise. The cost of housing is much higher there versus Anchorage, Alaska. Yet in Portland, I would make more than Anchorage, and the cost of a dozen eggs in Anchorage is $4.50. That's not organic. That's just regular eggs. Then again, you're in Alaska, so you can't really raise chickens there. And I mean, you could, but that would require a lot of work. Versus Salem, where a carton of eggs is $2.56 for a dozen. I roughly pay for organic eggs, with tax, I'm looking at $3. You can get eggs here for 89 cents a carton. Looking at that housing market is just, it's a bad time. It's a bad time. With that being said, though, this concludes the final project. Let's see. So, where I have learned much, I wanted to thank Miss Benzie for being the best teacher that she is. I have learned so much. I will miss you, but I will not miss the math, although you did teach me plenty. So with that, I sadly say I rock plus you rock, which means we rock. And I can't wait to see you again, Miss Benzie, at the final bash. So with that, signing off, good night.